Welcome again. Today we'll look at the empirical formula and how you go from data on percentage composition to the empirical formula. Now, the empirical formula is the simplest ratio that you can use to express the proportions of the atoms found in a molecule. Take, for example, C4H8. This is its molecular formula, but the empirical formula would be the simplest ratio between carbon and hydrogen. And this reduces to C1H2. And generally, wherever you have a 1 in chemistry, it is excluded and understood. So the empirical formula could be expressed as CH2. But how do you solve a problem like this one? An organic compound A contains 62% by mass of carbon, 24.1% by mass of nitrogen, and the remainder is hydrogen. Determine its empirical formula. Now, to do this, you begin first by determining the percentage of hydrogen, which is not given in the question, but you can find it by taking the sum of 24.1 and 62 and minusing that from the 100%. To get a value of 13.9% for the amount of hydrogen in the compound. And now that you have the percentages of nitrogen, carbon, and hydrogen in the compound, what you have essentially is how many grams of each you would get out of a total of 100 grams. So we can envisage that you have 62 grams of carbon out of every 100 grams of this compound. If 62 grams can be carbon, from the periodic table we can tell that the relative atomic mass of carbon is 12 grams per mole. Then we divide the percentage composition out of 100 grams, so here expressed as 62 grams, divided by 12 grams per mole, and this would come to an answer of 5.16 moles, with the grams cancelling. Doing the same for nitrogen would give us an answer of 1.72 moles. And doing the same for hydrogen, 13.9 moles. Notice, here I've written 12 grams per mole, and here I've written 14 grams mole to the power of -1, which is the same as grams per mole. In each case, the number of moles of each element out of the 100 gram sample is determined by dividing 62, 24.1, and 15.9 by the relative atomic masses of each element. So basically what you have is the mass in grams out of 100 grams divided by the atomic mass. And these three values are then considered. And you divide by the lowest value as a common denominator in all three values. So for nitrogen, that comes to 1. For carbon, 3. And for hydrogen, it comes to 8. So with this ratio of 3 carbons, 1 nitrogen, and 8 hydrogens, we get a simplest possible formula for this compound of C3H8N. And this is known as the empirical formula.